Nowadays, tuberculosis takes more lives than any other infectious disease. Cases are on the decline, but emerging antibiotic resistance threatens to interrupt that pattern. I'm Tamsin Bell, and I spoke with Professor Francois Balloux from University College London to learn about how this infectious disease evolved.
Historically, TB, tuberculosis, was terrible in the UK, but it's still a major problem. There were some hopes that it could be controlled or possibly eradicated. However, over recent years, we're seeing increasing resistance to drugs, which makes it very difficult to treat people. We've been using the same antibiotics nearly for 50 years now, and resistance has been emerging and is spreading. And it is becoming increasingly difficult to treat TB because we are running out of drugs, essentially.
Why were you investigating this disease?
We had actually two goals. We wanted really to understand where it came from, how it spread globally. And the second objective was to understand the frequency of the emergence of the antibiotic drug resistance and how they spread throughout the world, whether they spread more locally, more globally, and let's say what we can do to limit this spread.
And what did you find?
The most common form of TB, which is so-called lineage 4 or L4, emerged in Europe about 1,000 years ago and then spread to different parts of the world with European colonization. And the second question was about the frequency of novel emergence of drug resistance versus their spread. And here we realized that, which was a bit of a surprise, that most of the emergencies are local and tend to spread at least at the level of the country rather than globally with global migration.
You mentioned lineage 4. What does that mean?
TB is a fairly diverse pathogen. It is subdivided in a series of lineages. The lineages that are really specialized on humans have been divided in a series of 7 to 8 different lineages. The one that you find everywhere is so-called lineage 4.
So this lineage 4, the big problem, how did this evolve?
We don't know exactly where it jumped from, or let's say how it evolved exactly, but it really emerged something like 1,000 years ago. At least from an evolutionary point of view, it is a relatively recent disease. And what we also found, which is interesting from a historical anthropological point of view, is that the spread of this lineage to different parts of the world followed really the European expansion colonization. So, for instance, one of the most striking findings is that the arrival of TB in the Americas, it fits extremely well the arrival of the Europeans. And that also is in line with the increasing evidence that there was probably no TB in the Americas before Europeans arrived there.
I see. So the Europeans infected the Americans with tuberculosis.
I'm afraid.
Can you tell me a bit about the samples?
This is all based on so-called whole genome sequencing. So essentially we decode the genetic sequence, the whole genome of these strains. And in this case, we relied on slightly less than 700 different strains from all over the world. So most of them are strains that were collected from patients over the last 20, 30 years. However, we also have more exotic types of samples, either obtained from ancient human remains or from mummies, or some also are from patients but are slightly older and were collected and left in freezers for a very long time. And so it's by far the most comprehensive data set to date.
Oh, wow. So are these like little bits of skin, or what kind of sample do you need?
For modern samples, you would collect saliva. However, for ancient samples, these would be bones, or in the case of mummies, soft tissues.
So what does this tell us about antibiotic resistance?
What we know about antibiotic resistance is when we use a drug for a long time against a specific infectious disease, a specific bacterium, we see resistance emerging. We've been using now the same drugs for over 50 years on TB. So one could even wonder why the problem is not worse. However, what we don't know so much about is, let's say, the rate of independent emergence versus the spread of these resistant strains from one patient to another. And I think this study, what it showed, which was actually a major surprise to us, is that the vast majority of transmission tend to be very local scale, let's say within a city. And I think there's a positive surprise because this really suggests that local initiatives to control drug-resistant TB actually are very worthwhile in the sense that even if you eradicate it locally, this is still extremely useful because you don't necessarily have a rapidly influx of resistant strains from elsewhere.
Can you tell me why your results are important and what the implications are?
They are very interesting at two different levels. One is this very fundamental level. It's about, let's say, how old is this disease? When did it emerge? Where did it come from? And then I think the second type of results, which are also very important, are about the lower spread of these resistant lineages than what we had expected. And I think from a public health perspective, that's actually very, very important. I'm much more optimistic now than local programs actually really are useful because they won't be swamped by resistant strains coming from elsewhere.
That was Francois Balloux from University College London, and their results have just been published in Science Advances.